Good afternoon. My name is Cristina Palés. I am the Marketing and Communication Manager at Johan Cruyff Institute. Welcome to our third webinar in the series on Web3 and blockchain, done in partnership with Zetly. Today, Kevin Healy from BSV Blockchain Association will lead us through maximizing data potential in Web3 for football clubs. In this session, we'll explore the crucial role of data in Web3. You will learn practical strategies for data collection, storage, and integration tailored to sports clubs. Plus, see how blockchain can make data management more secure, showing why it's vital in the digital era. For more on the series and future webinars, visit our website. All sessions are available on the Johan Cruyff Institute's YouTube channel and on our website, making it easy to watch again or share. We hope you find this webinar informative and enjoyable. Thank you for being here.
Okay, great. So this is our last webinar of at least the one that I'm presenting. We're going to have 3 more presented by Zetly. And so let's go ahead and get started here. So this is what we're going to talk about today. First thing is going to be the importance of data. Okay, this presentation is all about maximizing data potential. So we're first going to start about, well, why do we want to, collect data? What is it that's so important about that? And then we're going to talk about how the blockchain helps us with data collection, storage, and security. Okay, and then finally, we'll talk about some applications for sports clubs, and then we'll do question and answer. Okay, let's go ahead and get started. So you might have heard this phrase that data is the new oil. Okay, so if you look back at the largest industries of the 20th century, it was the oil industry, right? There was all these giant companies, whether it's Standard Oil or whatever, that were making fortunes off of harvesting oil. And it was leading to the most dramatic, quality of life improvements. Now we think of it as polluting or whatever, but back then, I mean, we wouldn't have, cars and airplanes and trains and all this stuff without this this resource that was being harvested. Okay, and so now in the 21st century, all the biggest companies that aren't oil seem to be dealing with information and data. So Apple, Microsoft, and then all the social media companies. Okay, it's all about harvesting this data. So a lot of times data, just like oil, it comes out of the ground unrefined. It needs to be processed. It needs to be properly managed and all that kind of stuff. And so we'll talk about some of that. Now, if you look at where does it start from, like where does this data come from? And I think the example of these Internet of Things devices are a really good place to start because they give an easy example. I've been installing these in my home where you control it, remotely from your phone, the lights and stuff like that. And it's really convenient. But then by having computers in your light switches, there's all this other data that can be collected. Okay, so what times was it turned on? What times was it turned off? How much electricity is it using? And all this kind of stuff. And light switches are a simple example, but you have the sensors on the doors, or you have the temperature and humidity sensors and all this kind of stuff. And when you look back at this data, this chart, it really tells this interesting story. And it gives you all these insights into how your home works that you wouldn't have otherwise had, right? And so this is a good example is as we integrate sensors into things, then we start having this byproduct, which is the data. Now you could just not track it. You could just leave it there and you would be missing out on all this new insights. So that brings me to the next question, which is, are you harvesting this data? Is the data that you have from all these sensors and Internet of Things devices, is it being collected and refined, or is it just sitting there? Or even worse, is it being taken by others, right? So with the social media companies right now, they have a lot of data about people and it's not in our possession. Okay. And even with maybe some Internet of Things devices, depending on the company that you use, they could either make it private and owned by you, or maybe they're just harvesting this data and they're selling it and making use of it in other ways, right? And so a question is, well, just kind of like how we were talking about in the other webinars, where we were talking about how Web2 is sort of modern day feudalism, whereas Web3, we're moving into capitalism, right? So we now have the opportunity to start monetizing this data. Maybe somebody wants to purchase, some data that you've collected. Well, now you could exchange it for micropayments or for larger than micro, maybe it's macro payments. You could exchange your data. Instead of it just being taken from you, you could actually monetize it, right? And the advantage of this isn't just because it's the right thing to do or whatever. It's because if we get the incentives right, then we could have a much richer internet, right? It's because, let's take this example right here of the weather sensors. Okay, so right now, if you want to check the weather, you go on the internet and the website is usually monetized by ads. And they'll tell you the weather in a certain city, but what part of the city and what how do we know that that sensor is in working? Where is that sensor and that kind of stuff? But imagine if instead of doing the ads, you actually paid for your weather data and you had it like within a certain coordinate, geolocation, and you basically make a bid, just like in the markets, you have a bid and an ask, right? So actually in this case, it'd be an ask, right? You're asking for data within a certain region, and then these suppliers of the information could start bidding on that data. Okay. And by having this happening, then you have market dynamics that will actually make the data more accurate, right? It'll, in the places that people are really asking for this information, then it will start to incentivize weather people to put the sensors there. So it's like supply and demand, right? And it helps us coordinate what is actually being asked for. Because let's say you have, in the ad-based business model, you have millions of people looking for weather in one area, but there's only like one or two sensors. And so it's not very accurate data. Maybe the sensor has an issue and it's not reporting correctly, but now millions of people are having the wrong data. Okay, but if we could actually, find out where people are demanding data, and then the market would fill in, and even if it's just one, because it's a small region, at least we'll know that, wow, this is a really valuable sensor. There's millions of people asking for it. They're all paying for it. And so we could invest in a really good sensor for this region. And for the other regions, we'll just use whatever because there's not much ask. So this is sort of the example. I'm going to go back to the previous slide, right? So you have all of this incentives where if we're actually getting paid for placing things, then we could have a richer internet. And it doesn't have to just be weather data. It can be all sorts of data, right? And right now, again, in this top thing, it says it's being collected, but is it being refined, right? Is it being presented in such a way, as we see on the right, where it's easy to understand? Is it presentable? Does it actually give us valuable information, or is it just, this raw sort of just tables and tables of data that nobody really makes sense of, right? So this is the importance of data, right? And we'll talk about some use cases in the football industry, but you could obviously see tons of different ways, not just with weather, but with other things, and why data is so important. Okay, so part 2, data collection, storage, and security. So we've talked about this a little bit in the previous webinars, but it's really important to repeat here. So there's this common misconception that you're going to store data on the blockchain. Okay, now it could just be a vernacular sort of confusion with words, because what you could do is you could pay to have somebody store your data using the blockchain. And it's basically, indexed and paid for by the blockchain. And so in a sense, it's stored on the blockchain. But in practice, you're not going to store any data on the blockchain, because as the transaction pool grows, and as you have, these really large blocks, miners don't have to keep your data, okay? And they have no incentive to, provide this infrastructure for you to be calling them, asking for that stored data, okay? So it could get pruned, and it could, they just keep the hash chains, which gives evidence that it existed, but it doesn't have to store gigabytes and gigabytes of data, okay? So it's really important to understand you don't store data on the blockchain, okay? Instead, you basically index or timestamp the data on the blockchain. So the data can be stored in your cloud, like people are doing now, on your server at home, on your computer at home. And you can have a timestamp that basically proves that it existed at a certain point in time. Okay, so, and that's totally fine. Okay, but in the future, as this platform evolves, you'll start to see, and there already are a few from Project Babbage and stuff, but it's very in its infant stages, and it's not as robust as the services today, like Amazon and stuff. In the short term, it's probably obviously better just to use Amazon or your own servers or another company's servers, right? But in the future, as this technology evolves, there'll be the opportunity to have, the data stored by other people, and then you're paying to have them store it, and you can pull it all together with your keys, like we've talked about before, where it could be distributed among a bunch of other services, and then you're the only one with the keys that can make sense of it, and it's stored, on these servers, but it's all made possible by the blockchain. Okay, and that's where you say Bitcoin, or my data is on the blockchain. It's not really on the blockchain, it's just indexed by the blockchain. Okay, so data integrity is super important, right? So if somebody gets into your data and they start hacking records, right? Let's say they get into your server and they start changing things around. But let's say you're like a bank and you have mortgages, where you have, hundreds of thousands, millions of mortgage records, and everybody has their own different rate and stuff like that. And if a hacker gets into that and they start changing things around, then how do you just double check that, oh my gosh, it was these mortgages that changed? You have no idea, because you have so many records, right? And one of the things that hackers will do is they'll erase like the logs, right? So any of the changes that have been made, you don't know what has been changed, okay? And so technically speaking, you would have to, in that situation, review everything and go back to your source records, the paper and all that kind of stuff, to rebuild your database. Okay, well, that would be the most giant, project, and a really large cost, okay? And so what we want to be able to do is to have a chunk of data that has this fingerprint, okay, these hashes. And we're going to review what the hashes are in the next few slides. But you want to know that up until this point, nothing has been changed, okay? Or in these from here, you know, 1900 till 1950 or 1950 to 2000, whatever your time period is, you have a hash of all that data. And if a hacker gets in there and were to change things, then you would know the change happened in this zone, and you could start to figure out what had changed. And instead of having to update your entire database from source records, you would be able to say, okay, we need to update this region. And once it's fixed, then the hashes would all match and you'd be back in business. Okay, so again, what the heck is a hash function? We've talked about it before, where it's like a fingerprint for a chunk of data. Okay, so you have, it could be a megabyte, it could be a gigabyte, it doesn't really matter the size of your data. But what you do is you run it through a hash function and you get this small unique identifier, okay, a fixed length. So it's going to be the same size fingerprint, whether it is a gigabyte of data or a megabyte of data. Okay, it's all just this fixed bit length fingerprint. So if you were to change just one, you know, little thing within that gigabyte of data, you'd get a totally different fingerprint. And not just like a fingerprint where like the, you know, one line is a little bit different. The way hash functions work is that when you change just one bit in that huge gigabyte of data, the entire fingerprint will be like unique, okay? So they're a very, very useful way of verifying that a big thing of data hasn't changed. And it plays a crucial role in the blockchain architecture because it's used to make sure the blockchain doesn't change. And the benefit of it is that you can have this huge amount of data that you're verifying hasn't changed, but you have this really small file size for the fingerprints. So what happens with our architecture in BSV blockchain is that we distribute the fingerprints to the network, right? All the users can have a copy of these fingerprints and they can use it to verify that nothing has changed with the history of the blocks, but they don't need to keep gigabytes of data on their device, right? They don't, it's like with the BTC blockchain, they want everybody to have a full node. They want everybody to have a full copy of the blockchain, but that doesn't scale. And it's why, you know, in pursuit of that mission, they've kept the block size at like 1 megabyte or 2 megabytes or whatever. It's so small. And they want it so that everybody can have a copy of it. But if everybody's going to keep a copy of it, it's bound to the, you know, the size of the total blockchain, and can people fit that on their computer? It's why it only can do 7 transactions per second. And then if you could only do 7 transactions per second, well then, you know, if somebody wants to make a transaction, then they have to pay $20 to be one of the 7 transactions that could go through, right? So with the BSV blockchain, we followed the original intention of Bitcoin, was that the blocks would get infinitely sized. And what we would do is we distribute these hashes of the data, right? These fingerprints. And so you wouldn't need to keep an entire node or copy of the blockchain on your device. You would just know by these hashes that nothing has changed. Okay, now you might be wondering, okay, well, how do hashes work? How do we know that they are, you know, have integrity and stuff like that if we're going to be relying upon them? So this is the simplest way that I could explain a hash function. So there's these this game called Plinko. You see it with like, carnivals or lottery games where they'll drop a little ball and it goes through these pegs, and at the bottom, it ends up in one of these buckets. Okay, so this is a pretty good metaphor for how a hash function works, except that instead of just 5 buckets at the bottom, there are like more buckets than exist as atoms in our known universe, right? It's a computer program, there's huge amounts of buckets. And then instead of just, 9 rows of pegs and 5 pegs wide, it's probably even wider than what's in this generated picture right here. But it's like, just imagine trillions and trillions of pegs, okay? So when you drop a chunk of data, it's going to go all through this thing and it's going to end up in one of these buckets, okay? So with early versions of hash functions, they would have what was, and sometimes even still today with the ones, you could have a collision, okay? And a collision is where you have 2 different pieces of data that end up in the same bucket, okay? They actually get the same fingerprint. It'd be like if you found 2 people that are different people that have the same fingerprint. And so then, even though this is going to happen about 0.0000001% of the time, then if it did happen, then you would up to more pegs, okay, and more buckets at the bottom. And so you go from SHA-256 to SHA-512, or from SHA-512 to, 1024. And what that would, do is it would just make it even less statistically possible to get 2 different chunks of data into the same identifier bucket. Okay. So, and even if you did have 2 chunks of data, it's one thing to have a collision where 2 people have the same fingerprint, but it's a whole other project for a hacker to be able to design a way to make it so that 2 different things have the same bucket. Okay, that's even more difficult. And usually what they'd have to do is add a bunch of, like basically data. They have to append it to the doc. So let's say it's a PDF, and there'll be like this really large thing at the end of the PDF with all this data that is inserted in there in order to make it have a collision with the document they're trying to forge, but it'd be obvious because there's all this appended data. Okay, so again, it's basically impossible. I'm not going to say impossible because there's a 0.0000000000001% chance of a collision. Okay, so it's basically impossible to get a collision. Now, if a hacker was to design a collision, it'd be obvious they did it because they'd have to append all this data. Okay. So anyways, hash functions are used not just in the blockchain, but in many parts of, the computer industry and computer science. Like when you type in your password into a website, instead of them taking your password and checking to make sure that it's the password, they have basically, when you created your password, they hashed the data. And then when you type it in, they hash it and verify that the hashes match because they don't want to collect your password. So anyways, the point of that is just that it's used in a lot of different areas in the computer industry. And so these hash functions are, well maintained, and people are inventing better ones. And again, if there is collisions, you can just increase it. Or if there is some super fancy computer in the future that is so fast that it can generate collisions, then we just up the number of pegs and the number of buckets. Okay, so just for review, you take a data, you run it through all these pegs, it ends up in a unique button. Okay, and that's where you get the fingerprints for a chunk of data. So you don't even have to understand, all the thing under the hood. You just know that you throw in a bunch of data, and what you get out is a fingerprint of that data. Okay. But then with the blockchain, it uses these hashes to then verify that no previous blocks have changed. So I don't know if you can see my mouse, but what I'm doing is I'm hovering above this top left image here, and it's showing that this is a block. Well, this is a transaction, but it could also, you know, if you ignore the signature part at the bottom, you could say that this is a block. And so you have a block of the hat, or a hash of the block, and then the next block includes the hash of the previous block, and then so on. And so if you were to change one bit of a previous transaction, it would completely change all the other blocks, okay? And so all the other hashes. And so you would say, okay, well, something has changed. These blocks of data don't match. Okay, so it prevents the previous things from being changed and everything later. Okay, so that's how we have the immutability. So then you have these collection of fingerprints, like I said, that can be distributed to the users of the blockchain. So they don't have to keep petabytes or terabytes, you know, just tons and tons of data that's going to be generated through the blockchain. There's no reason for them to keep that on their phone. What they do is they keep these hash headers, which are a little fixed length thing. It's, you know, like, I forget exactly, it's like 52 characters long, okay, for each hash. And then they just keep that on their phone. And so it could be, you know, megabytes or hundreds of megabytes, but that's doable, especially as our phones continually get larger and larger hard drives and smaller space, okay? And the cost of storage in the computer industry is going down, right? And so people can keep an entire record of the hash headers on their blockchain. Okay, so let's go ahead and talk about some applications for sports clubs. And let me just say, you know, we're talking about data collection, storage, and security. So just to review, data collection, you're going to keep this on your existing servers, and you're just going to timestamp and keep a, you know, a hash of your data to verify that nothing has changed. And so the storage, the collection part really remains the same. The storage, you can keep it on your own server or on somebody else's. And in the future, you'll be able to pay to have other people store it, and you'll have the keys as it's distributed just to pull it in. So you could have sovereignty. And then as far as the security part, you can use these hashes and these timestamps to verify that nothing has changed, okay? So you can prevent a hacker from getting in there and changing a bunch of things without you knowing what has changed, okay? And you can timestamp things. You could even have a record, an immutable record of all the changes that have happened to your server, okay? And so then if a hacker gets in there and makes administrator changes, there's a record that they can't just erase, right? Because that'll be the thing that hackers will do, is they'll erase their trail, right? They'll cover up their tracks. Okay, so that gives you that. So let's talk about some applications for sports clubs, right? So let's say, you know, you guys know your industry better than I do. These are some ideas of what I've had, but, you know, anywhere that there's data, then you can have it stored properly, right? So maybe it's records of, you know, who scored the most goals in 1990. Well, nobody's really monitoring that data too much, because it's something that you only look at once every so often. Okay, but if we could actually make sure this data has integrity, and so nobody can hack in there and erase high records or whatever, because maybe they say they have the world record of all time, but actually they didn't. Somebody else did, but the data was erased or something. But more importantly, maybe like health records, right? We talked about this in a previous thing, a voice memo with player transfers. Maybe you want to have, records of all sorts of things that they've done. Maybe they have to, measure their ability every so often, and then you keep a record of that can't be changed. And so you can see that, yeah, this player ran this fast in year 2024, and then in 2023 they ran this fast, and they're getting faster, they're not, okay, stuff like that. Nutrition, right? What food, one of the apps that I developed, and I've been very careful about, who gets the data of what I'm eating, because I don't want people to really know, right? But for me, I have the record. So one of the apps that I've built is called MealCam, and I keep track of everything that I've eaten back since like 2018. But then for me, when I look back at that data, I say, oh my gosh, I know that I felt this way because I was eating that, right? But maybe for sports, and it's very hard to enforce, that people are going to take a picture of everything that they eat. So I designed the app to be like just more of a personal thing, where if you're cheating, you're just cheating yourself. Okay, but if you could somehow figure out, maybe it's just on the game day or whatever, you're able to track what everybody eats that day or the day before. Okay, how did that choice of food affect their performance? Okay, or if people took ice baths or got a massage or did some sort of, crazy, like other type of body work, then how did that affect their performance, right? So these are the types of things that you could measure. And really, the blockchain, it just comes in here for data integrity. You're just making sure that nobody's going to hack or change the data. But at the end of the day, the data that we're collecting is just data. So if all the stuff is on a server, it's on a server and it's fine. But it's just, the blockchain doesn't really add new things in terms of this breakthrough of ways of doing data collection. It just gives you integrity. Okay, and you're able to prove that this data existed at this point in time and it hasn't changed. Okay, so a lot of these examples are just stuff that you could do today, even without the blockchain, right? So we talked about like, well, what if you have sensors in shoes? Or what if you're gonna, have sensors that people wear? Okay, well, how could this be useful in sports? Well, maybe with all this data, you can start seeing that there's some pattern. Maybe some certain players will historically have always scored from a certain point. Okay, and if you don't collect this data, you don't really know. You just know, oh man, this guy scored so many goals. Okay, but if you actually can see and map, this is where people scored from, well, that's a pretty awesome advantage, because as a defensive, when you're defending, okay, if we can make sure that this person stays out of their hot zone, then we can prevent them from scoring. Okay, or if you also know that your player always scores from here, then offensively we need to make sure that they're in that zone, and so we can defend that area so that they can get into their hot zone, right? So there's all sorts of different things that you could imagine are possible with collecting data. Okay, so as far as competitive advantage, there's all that stuff, and then all the merchandising and all the the sources of inputs that you may use, whether it's medicine or nutrition, or for the players, or whether it's selling things like the collectibles and stuff, all the inputs that are coming into the football club and the stadium and stuff like that. The blockchain could help to verify the provenance of that, right? So supply chain stuff. So that it's a huge, it's probably not something that a football team would want to get involved with, but as industries evolve and start to adopt the blockchain stuff, we'll have, more traceability of the products, okay, that are coming into places. And this is super useful because let's say you're going to sell organic food, or you're going to sell a collectible that's only signed by, there's supposed to only be 10 signatures on this jersey or whatever. There's a limited number of this authentic merchandise. Well, you can use the product to prove that it's one of the 10, okay? Or in the food example, that it is organic food. It's not counterfeit, right? So this is a huge part of, the blockchain industry, is provenance through the supply chains. Okay, and then my favorite example that I think we've discussed so far in this webinar series was the idea of, issuing fan tokens where they can, be buying experiences with these tokens, or voting on maybe this, fantasy league of, they think this player is going to win the most, or this is their favorite player or whatever. And so you kind of have this this market dynamic where the fans are participating in valuing the players, okay? Because let's say that you are recruiting a player and you're going to pay them however many millions of euro a year, okay? Well, are you paying them fairly compared to what they're generating in terms of revenue for the football club? Okay, right now it's sort of a guesstimate, but if the player or if the fans were involved in this, and they're the ones ultimately that are buying the tickets or watching it on broadcast, okay, if the fans were somehow what they value was measured, then you could more effectively, pay the players. I gave the example of like with streaming. So you're streaming music, and in the past, you would actually go and you'd have to buy an album, or you'd buy a song when it was on iTunes. And what this did was it communicated that you value this. Whereas now when you stream it, they get paid when you listen to it. Okay, but listening and giving your attention to something is different from valuing something. Okay, you may have a collectible that you really value that sits on your shelf and you never use it, but you value it, okay, or a piece of art or whatever. And so attention is different from value, right? Those are two different things. And right now with social media, everything is based on the attention currency, right? It's all what gets the most attention, which, for advertising and stuff, it's valuable because you want to expose your ad to a lot of people. But if we can move away from the ad-based business models and we can start paying directly for things, then, what do people value? What do they actually communicate through their spending? It's very important, right? And so by issuing some sort of fan token where there's a limited amount, it becomes like this currency where you can start having fans engage with that currency and it can communicate value. Okay, what gets people's attention is still important. You could obviously want to keep track of that, but what do they actually value? Okay, there's a lot of things that I value that I don't give my attention to 24/7 or want to give my attention to 24/7. All right, so I think understanding that, spending tokens is a form of data collection, right? And you can start to gather what people value is another thing. All right, so that's the end of this presentation. And so we'll go ahead and take question and answer. Let me go ahead and pull up the chat here. Okay, so if you have any questions. All right, well, I don't think there's going to be any that come through. So my email is kevin.healy@bsvblockchain.org. If you have any that come up, you could go ahead and email there. And thank you for attending these. Again, in the next 3 webinars, you'll have a person from Zetly that's presenting. So this will be the last time you see me in this webinar series. So thanks for watching, and I'll see you in the future. Bye.